Okay, good morning. I think I can say good morning at 11:30. We have 11:38, so we're 8 minutes over. We waited a little bit longer, and it's time for our first info session related to the upcoming Protect Purdue hack. I hope that you can all hear me. If not, quick sign would help. Okay, so let's get started. It is today November 23rd, and we are going to launch Protect Purdue hack that is powered by IronHacks. And my goal today is to first give you an introduction to who's behind IronHacks, that you know who we are, tell a little bit more about the philosophy of IronHacks and what our goal is, and then actually give you some insights on August hack, what the task was there, that gives you an idea what the upcoming hack will be about, because there are 2 hacks related to our COVID-19 data science challenge. So let's get started. Our code is a research center at Purdue. It cuts across all the different disciplines and colleges. And we focus on digital technologies and their ability to empower individuals to use them to solve grand challenges, societal challenges. And say digital technologies, you know, one really important one is cloud, but also machine learning, IoT, mobile, and social media. But in the end, what we are looking into is how digital platforms, social media can enable you to actually use not just your voice, but also your hands and your analytical skills to solve societal challenges. We come from different backgrounds. We have people that deal with behavioral questions, social sciences. Why do we interpret information a certain way? Why do we share information? And we have also people with strong technical skills that help us work on building platforms in machine and testing in the field. Our work has been sponsored by National Science Foundation, other research institutions, but also we work a lot with industry partners that think that it's really important to foster open platforms that give everybody out there, every citizen, a hand to contribute. Here you see on this slide just a few faces, people that are part of our Cody and that are passionate about digital technologies and want to make a contribution. Myself, my name is Sabina Brunswicker, and I founded our Cody, but there are many others that have a similar passion. So what are IronHacks? The name, inspired by Iron Man, is hacking in cycles, that you actually experiment different things, go through different phases, you can learn, you can improve, and not just a one-time submission where you get evaluated and that's it. So you have multiple iterations and you have multiple times to get feedback. And for sure, it's also about changing the way actually problems are solved. In the past, we thought problems can only be solved by people that are hired, that work for big companies, and that are walled off from the rest of the world. IronHacks says, you know, there are people out there, hackers that have creative ideas. I'm not talking about hacking in a way of breaking into the system, hacking using technologies and solving challenges in a new way, just in a creative approach. And that's what IronHacks is about. And It follows a trend we've seen over the last years. You have heard of Netflix, you might have signed up to Kaggle, you have maybe signed up to Topcoder, where you have a challenge and you're part of a community and you try to solve that challenge and you submit it. What's unique about IronHacks is we argue it's important to have iterations. So IronHacks is a platform where virtual crowds use data to solve those societal problems. And when I say societal problems, we talk about healthy living, we talk about affordable housing. And now, 2020, we also talk about COVID-19. It's a societal challenge. It's really important to find solutions for that. And it's not just related to medical issues, finding a vaccine. It's also about understanding how we can actually help people to change their social patterns as we're moving through this pandemic until vaccines have arrived. IronHacks supports that. It's different from the classical hackathon, as I mentioned earlier, where you have maybe 1 or 2, maybe 3 days. You typically go there physical. You typically deal with issues like proprietary code, and it's a bit messy. That's a quote actually from one of our participants, compared to Purdue IronHacks, where we have multiple iterations. We used to have 4 to 5. Sometimes you also have 7 or 8 phases, iterations where you can submit, and then you also have virtual presence. So you will have access to very unique data. That's also one of our key benefits, that you have data that are real world, that are unique, not necessarily those that you find in a public repository, and particularly big data. It's a competition, and you can also gain fame because we've published the final models on our website and also share it with our partners. Key partners are governments. The state of Indiana, for example, the chief data officer who you see on our website is speaking to you there, or the Department of Workforce Development, the city of West Lafayette, and with the upcoming hack, also Protect Purdue in other centers on Purdue campus. I talked about iterations earlier. Purdue IronHacks is really about iterations, multiple stages where you get then immediate feedback. So you have a submission, and afterwards you get evaluated very quickly. You're trying to do this real time, so just a few hours later you see your scores. And what are the key features of the platform? I'll be going actually to the platform in a little bit, but just to summarize, you have a registration, you have an overview of different hacks that you can see and browse and decide. You have a dashboard. In the dashboard, you get insights about your current standing. You can see your own score. For example, if you look into predictions, what's the mean square prediction? How much do on average your prediction deviate from the ground truth? We'll also have additional metrics, for example, looking into your effort. Then you also can compare yourself to the rest and the summary statistics. And I think one of the key essential features on IronHacks is a cloud-based editor, a Jupyter Lab. That's the next generation of Jupyter notebooks that provides your state-of-the-art environment for data science, as you can also find it on other platforms like Kaggle. And then we also do have a formal announcement board. We are informed about upcoming things. The platform has been developed as part of research projects in the past with the goal to also run research in the field. So our goal here is, as we're moving through this, to also better understand how can we make hackers more productive? How can we also use nudges, information nudges, to trigger your behavior in a certain way that you can become more productive, that you can see what you should do next. So we have the ability not just to scale, but we also can actually do randomized field experiments. So as you're moving through this, you also be part of a research study, and that's why you also have to then consent to that study as you then actually accept the terms of the competition. Overall, we have had several thousand participants in prior hacks that have gone through the process. They've gone through an iterative process building solutions for societal challenge, with the goal to also to study them. And we have also some related publication that if you're interested, you can look into, and we're working on additional ones to understand how the platform design and the feedback in particular affects the performance. There are benefits for you when you participate. Besides career opportunities, you can use the project that you build and the certificates that you win also as a showcase when you apply for jobs. Every participant gets a certificate. There is prize money. We awarded several $1,000 in the past, and we will do so in the upcoming Protect Purdue hack. And in the past, we've also given class credits. And there's also for sure the global recognition that you can achieve because you are actually featured on the website publicly. I have to tell you that in the past, IronHacks was not about data science per se. It was not about building statistical models to make prediction. It was about web development, where you have like an app that meshes up data in a so-called mashup, and that mashup typically has three components. It has a map, a data visualization, and has an interaction form. Those apps were built in HTML, JavaScript, and with D3.js, so primarily web programming skills were needed. And that's why you also see some of the showcases on our landing page having a nature of an interactive mashup. For example, here you see one where we ran a challenge in the past where a student had the task to build a mashup that gives new incoming citizen students that got accepted at NYU a way to understand where they can find an affordable and safe place to live. If you go to the website ironhacks.com, you can actually find some of those apps there. We've shifted our focus in 2020. We've moved away from web development. We focus on data science, and that's why we now offer a Jupyter Lab. And that is the next generation of Jupyter Notebooks. It is a web-based interactive development environment that allows you to load notebooks, but you can also actually open a terminal, and you can also use a console. However, the primary use now in these upcoming hacks is actually notebooks. It supports a wide range of workflows and data science. So in case you have worked with a Jupyter Notebook, that's nothing new to you. If you have come from R and you have used R Studio, it's slightly a slight change because that you can actually also write R code in Jupyter Notebook. We also do have a Bigquery integration, and with a Jupyter Notebook, you can actually then query the data with Bigquery. What's Bigquery? Bigquery is Google's flagship of data warehousing. It offers the access to data stored in tables that use the SQL standard. You can actually explore the data without pulling them in memory. And so if you deal, for example, terabytes of data, that's a great thing to do because you don't actually have to worry about your computer power, how much you can bring into memory, whether you're running out of memory and processing capacity. So it prepares actually for the future because the future is big data, and the more big data you have, the new environments you need. So it's no setup. You can just go there and actually access the workspace. So it's a bit like Kaggle. Let me do this at this point. I'm going to just switch gears right now. I'm going to go to the platform. Should have signed out at this point. To also show you this a little. So when you go to the platform, you sign in here. It's a Google registration, so you need to have a Google and an account, an email account. Once you sign up, you see here the different hacks that we are offering now. And you see there are two hacks. So one is Python and one is in R. So we did this on purpose because there might be people that prefer to program in R and others that prefer to program in Python. So you should then register accordingly. Let me just go to one that we ran in the past and also show you a little bit what it will look like. So here you do have a forum, you have the results, you have the rules, you have the submission, you have the task, you have the tutorials. But the most important feature really is here the workspace. The workspace brings me to Jupyter Lab. And in the Jupyter Lab, so here right now I'm actually loading a tutorial. You have a notebook, and the primary component of a notebook is a cell. So everything is in a cell. So this cell, for example, now has Markdown language. And later on here, for example, that's run in a Python, it runs a Python kernel. Yes, it does. And here you do have then a cell that has this code and then you can also put in their raw text. I'm not going to run this, but what's really great about this that you don't have to worry about setting it up. You can just go there. You can load down data, as we'll show you in the tutorials, and you can just get going. Also, important feature to point out, if you have a question, just send us your note, get in touch. And also watch the forum, because the forum will give you, updates on what's going on. We post their information that's relevant. Also, you do have then a dashboard, and the dashboard that gives you also some progress. Where you are, you see your scores, but you also do have summary statistics. Sorry, I should have gone here about metrics. We'll talk about this a little bit more, what metrics we publish here, but you also have the opportunity to actually look at other submissions. The details about how you were scored are actually customized per hack, because each hack is a particular task. So there's no standard metrics that we're using across all. If there are similarities, we'll slightly adjust it. You typically compete with about 30 participants. That's kind of the size we're looking into as we are running studies on this. So you do actually have a relatively, small group that you're competing with compared to, for example, CAG, where you compete with hundreds or thousands. It's very hard to actually win a competition. So now a few insights. Let me go back to presentation mode. A few insights into the COVID-19 Data Science Challenge, and also why we're running those. Prediction is really important for COVID-19. And as you might have followed the press and the news releases, predictions about how many cases will we have in the past, how many deaths will we have, the model beginning were really changing all the time, and prediction changed all the time because there wasn't sufficient data. We didn't have sufficient tests, etc. Now as we're getting better data and people try different models, the predictions become more reliable. At the same time, here we're dealing with a social phenomenon, so we have social data. So people's behavior are not necessarily always linear. So we have, because it's a complex system, we have constant changes. However, it's important to make prediction. So while there's been some nonlinearity at certain points, here I'm showing you here in the lower part, I'm showing you, I should actually use a pointer here. I'm showing you a chart that shows foot traffic, and certain types of places here clustered, like bars, hotels, etc. And you see that when we actually had the first COVID cases in our country, in the United States, we had this huge drop. But then the foot traffic was increasing as we slowly got used to that. We removed the lockdown, and then certain stores opened again. It was kind of a linear pattern. However, it was not clear what the actual foot traffic would be, and it's really important to also inform policymakers, governments, etc., all the time about what the foot traffic is, how it will look like in the future, to identify those places where people crowd, because there are some recent insights that the infection rate is really high in places where there's a high density of foot traffic, where people actually come together and maybe cannot adhere to social distancing, for example, or face mask wearing policies, for example, restaurants. It's very hard to actually eat without a face mask. So there's some evidence that the virus spreads in places where people crowd. So that's what the hacks focus on. They focus on foot traffic at certain places or brands in our regions. And when I say regions, we're here at Purdue, so we focus on Indiana per se. So that's why the first challenge, the COVID-19 challenge, focus on in Indiana. Overall, these data science challenges are always about building a statistical model using Python or R code in a Jupyter notebook. That's very important. And then have a prediction. So predict based on historical data, time series data that are available in Bigquery to build a prediction. And then we evaluate those outcomes based on the predictiveness or accuracy. So how much deviation is there from the ground truth? So there's standard metrics that are used, mean squared error, absolute error. Since we're talking about your prediction, we call this MSPE or MLP, mean squared prediction error, mean absolute prediction error. In addition to that, we also look into participants' effort or diversification out there, trying different models, and then finally also the quality of the visualization. In the August hack, we had a focus on brands. So there are brands like Domino's Pizza, Target, etc., that have multiple places in the state of Indiana. So for example, Domino's Pizza, I think, has about 90 places. And so the goal was to identify which brands are the hotspots where people crowd in the future. So they have historical data, and based on that, you make predictions. So you have weekly data at the brand level. You had about 30, the participants had about 30 variables, such as how much time do people spend on average across all the PUIs at a brand, how far away did they move. We also had spending data. So we have how much money did people spend. And then based on that, participants had to develop a predictive model to make predictions about the foot traffic for the upcoming week. So if you had week up until week 35, for example, you had to make the prediction for week 36. I'm actually able to show you also the actual task here. So we gave them week 10 to week 17, and then week 18 was the prediction week 10 to 18, and then the next target prediction week was week 19. Why did we pick those weeks? Because week 10 was the week where we had the first, where we had the lockdown here in Indiana, and this was kind of the first drop, and then from there, we had kind of this linear pattern showing. We updated the data continuously. So in each round, we added a new week because we got new data in, and we shared them. And then we also had more information about the context and how it's evolving, with an opportunity to improve the model further. With that, you had to then create, based on the submission requirement, you had to create a CSV file. So the mission followed those criteria, that you had to produce a CSV file that followed certain standards in terms of how many columns, what you put in there. We also asked the participants to submit a notebook. In addition, we asked also to submit a model description and keywords. The data provider at time came from a company called SafeGraph. SafeGraph is a data provider that has a population of mobile phones in the United States, more than 80 million mobile phones, that create a representative samples of mobility patterns of where people move. It also provides us access to social distancing information, because using a geospatial data, you can also see how far are people moving away from home. And then you see also when there is no movement, so you can actually approximate when people are actually at home. So you do have also social distancing metrics. In this past hack, we only focused on the weekly patterns, foot traffic at major brands. In addition to that, also transaction data, that was credit cards spending, daily credit card spending, that we then aggregated up to the week that could be used. We all put that on one single table to make it easier to reduce the effort for data pre-processing. We tried to pre-process it as much as possible, removed and cleaned the data so that you can just simply query it. We do have other partners, I should say that, and now in the upcoming hack, we'll actually rely also on those partners to provide even a greater number of data sets. 13 variables in the past, and as we are now moving forward, we actually have more variables and more data. So I mentioned that what was the submission requirement, the CSV file. You see that here, you had to produce and output the CSV with unique identifier, the week numbers, and then the sum visit counts. That was the prediction that the participants had to make based on historical data. And in addition, then also a notebook in which they actually shared the code to use to produce those models. In the final submission, it was volunteered to also create a visualization. In order to be eligible for the prizes, it was actually important to have that visualization. We provide all participants access to a set of pre-installed libraries in libraries in R, you see here, libraries in Python. You don't have to worry about that. They're already all pre-installed. You can just go ahead. We also provide the documentation for that. That's all described there. The evaluation, as I mentioned, accuracy of the prediction was the most important one. In addition, also we looked into effort. Now, what were the incentives here? In the first pilot, it was a smaller hack that we ran in August. We had top 3 solutions. The best solution received $250, and then we went down to, I think, $150 and so on for the top 3. But we also offered an Improvement Spirit Award. So even those that didn't make it to the top 3 got financial incentive between $25 to $40, as far as I'm correct. Would have to pull out the task description. What's important, why am I sharing this? We not just award the top 3 solutions, we also adjust the incentives so that everybody who is actually participating has also financial incentive. In the Purdue hack that's upcoming, you actually bump up the financial prize money significantly. We will actually award $5,000 for each of the hacks. So Python versus our peak condition for that, that's kind of very important, is we need to have 60 participants. So there's a minimum number of participants that we need to actually start the hack. So we are not there yet. So if you're here listening, make sure you sign up. If you haven't registered and signed up, or ask your friends and family to participate, or I shouldn't say family or friends that are also data scientists, because that's the minimum number that we would need. There's also rules that you then have to accept before registering to the hack. So, for example, it's individual work that's not in teams. You will be evaluated individually. You need to make a minimum number of submissions. So in the past hack, it was 2 to 4. Empty or non-submission are not considered, are not eligible. We will not consider that as a valid submission. You need to also support the scientific research. These challenges are part of NSF-funded research effort. So that's why in order to, you have to actually fill in some surveys as you go along to be eligible for prizes. If you should use the pre-installed libraries in R and Python, unless you communicate otherwise, those are the recommended ones, and we will not change it throughout. So if you want to use something in particular, you'll have to let us know so that we can adjust it. But it has to happen before we actually launch the competition. Data usage, you would have to agree to the data usage agreement. As I mentioned, we use data from Safegraph. So the data are there for you. Typically, it costs like $5,000 a license to actually having access to the data. So you have access to really valuable data at this point. So because of that, you actually have to agree to the terms of the hack. And one of the key terms is related to how do we deal with this data. So in this contest, you're not allowed to use any other data besides the one that you have access to. And after the competition, your right to access and use the data we provide you expires unless you acquire further requests, and you have to actually talk to us and how you can have continuous access to the data. For sure, we also have an honors code. That's very important to keep that in mind. You're required to create your work individually in case you need additional information besides the work accessible via the platform. You have to actually share those as references. Links that actually work, you have to give us a reference if you use a certain tutorial, if you use a certain code that is published in Stack Overflow, you have to provide us with the official documentation so that we can trace it back. Otherwise, we will actually not consider your submission. How do we keep track of that? We run code clone, but we also look into external sources. So that's very important to keep that in mind. Be honest and share that information. It's clear. Programming is also a Googling task, but if you do think you're using a lot of information or you're actually building upon a model that you found online, you have to provide that information. Ownership of the code. By participating in the IronHacks competition, you acknowledge that your submission can be used for non-commercial purposes by the IronHacks team. So we follow a Creative Commons license schema here. Okay, so those principles that I just shared with you also apply to the upcoming hack. And the focus is just slightly different, and the reward and the incentive structure will also change. As I mentioned, we've bumped up the prize money significantly. And then the specifics of the task will be released as soon as the competition starts. So right now you see an overview page. Once we release the task and once we release the competition, you will see the exact details. It will be similar to what I just said, but we are not yet really releasing the exact task yet, because of the fact that we're running a research project, and once we have sufficient people, then we release it, and then it is fair for everybody because you didn't have more time than the others. So until the upcoming weekend after Thanksgiving, you will have that general information. It will be very similar to what I just said, and the rules will be also very similar. It's just that might be slight variations. The variations are related to, for example, what would be your prediction task. So prediction tasks in the past focus on certain brands in Indiana, and actually 300 brands in Indiana. Now we're focusing on the greater West Lafayette area. Why is this? Yeah, I'm sharing a screenshot actually from a Senate meeting. I'm a senator of the Purdue University, and there you see what Mitch Daniels said. You know, the risk is not actually in the classroom. Classrooms are pretty safe in terms of spread. It's outside. It's outside and there where people socially interact and where it's hard to actually adhere to the CDC guidelines. And those CDC guidelines are social distancing and wearing a mask. So, for example, as you have experienced, we've seen certain restaurants have restrictions and how they place people. Now we even went in a kind of partial lockdown in certain states again, certain counties. So those are the places that are risky. So what we're focusing on right now in the upcoming hack is not just on brands in Indiana, but actually places in West Lafayette and places where people gather. That includes restaurants, it includes churches. So we do have several thousand data points, POIs in this area that are then categorized in so-called CBGs, which are census groups similar to a zip code area. And there we're asking you to make predictions about social crowding. It means foot traffic. How many people go there per week? And how many people go there by the hour? Because that's what we see from a recent study that's been published in Nature, that's where the risk is. Why also now? This is just a screenshot that I took from a website that shows also the infection rate. So we have our COVID risk level right now is high. So November is a really challenging month, and that's why it's so important to also understand it and monitor it and make predictions. So in that hack, you will make predictions for November, and we give you data and that we've just mined and parsed from all those places that are real-time, relatively actual, related to foot traffic. We also give you data that we parsed from Indiana website, executive orders that you can use for training models. We also give you data about cases, weekly aggregated, all already pre-processed. You don't have to worry about that. We parse data. And in addition to that, you get also some information about the census groups. Those are areas, or areas of where several POIs are in. So the census is typically groups are used when census data are collected, and they also give us some insight about the census, the population, the age, the income level, etc. So you can use that to train your model, and then you have to predict it. In addition to that, we also ask you to create a visualization. Should have gone to the next slide. So there's two components to it, making prediction using very actual data, and then also visualizing that. The visualization will follow as we're moving through the hack. Again, we have multiple submission rounds, and we'll be publishing actually those submissions later this week so that you see the key dates. So we start on the 29th, and then you will have almost daily a submission opportunity. You have a minimum number of submissions you need to make. You don't have to submit every day. But it gives you an opportunity to evaluate your model again. So you just benefit from it. It's not required though. And then in the end, we also ask you to visualize it, because that's really important as we then using your model in the future, that we can also monitor it based on that. So I've said most of it. I just wanted to also point out here, as you're now listening to that, again, we have two challenges here, actually sub-challenges. One is the Python, one is the R on our website. And if you are more prone towards Python, sign up for the Python. If you're more interested in honing your R programming skills and also maybe accessing BigQuery, you should sign up for the R. You cannot participate in both, one or the other. You will compete against peers that work in Python or R, same language, not different language. So you have the same conditions. And you will also all have the same data or pre-process. I think I should just make sure I'll show you one more thing as I'm going there to the website. Let's click here. Let's just go out. So how do you do this? So you should be going in here. Oops. My internet seems to be rather slow right now. It looks like that I just got cut off the internet. I can't just right now. It's not loading the page for whatever reason. But let me just clarify for this. So you have to register actually. To go there, you see a blue button and then you register there. And then you also see a tab there that's tutorials. And there's 3 tutorials right now. A tutorial for someone who's never used a notebook. That might be important, for example, for R users. And not maybe for Python users that have already used notebooks, which just might be a refresher what a notebook is. Then there's a notebook there's a tutorial that's very important. That's about how do I actually query data with BigQuery, because that's something that you need. And I strongly recommend that you actually use that tutorial. And you can try it. We have right now some training data for you. We provided you some data on COVID cases and also testing cases and weather data. And then that is the data set you can play around and that you get familiar with that before we actually launch a competition, because you don't want to just try to access the data on the first day, because if you lose time, you actually want to work on your model. So make sure that you get ready for that. And then there's another tutorial that has some introduction to SQL. If you haven't done much SQL, just how do I, for example, join tables, because in this hack you will get data in 2 tables, and how do I quickly join them? How do I, for example, also then subset and explore the data? And that's something you should actually try before we actually launch a competition. You don't want to lose time with that in the beginning of the competition. We do offer also some actually live tutorials, and this is always accessible in the calendar. So you should actually click on calendar and you'll see where upcoming tutorials are, and there should also be reminders sent to you. Okay, that's it.